Okay, the today lecture topic is one-way ANOVA. So, as in my previous lecture, I have already discussed ANOVA analysis of variance, why not multi-T statistic test, why ANOVA. So, if you watch those videos, I hope that your concept about ANOVA will be clear. So, in this lecture, I'm just going to discuss a very simple example about one-way ANOVA. So, before going to that, you need to understand what is one-way ANOVA. So the one-way ANOVA, the one-way analysis of variance, is used to test the claim that the three or more population means are equal. So as the number of groups, as the number of population are more than 2, if there are only 2 population, then we can easily conduct a T statistic test. But as we claim that when the number of groups, when the number of type of data are more than 3, or more, then we will use one-way ANOVA. So why one-way ANOVA? Because in one-way ANOVA, because we will consider only one independent variable at a time. For example, if I give you a simple example, the impact of weight loss while drinking different type of tea. Let's suppose someone consuming black tea, someone consuming green tea, some consuming peppermint tea, etc., etc. So now there are 3 type of tea. So when we have 3 different samples, we have 3 different type of data and its impact on the weight loss. So weight is now in this case is the independent variable and all the other things are depending on it. So this is an extension of the 2 independent sample t-test. Because why this is an extension of 2 independent? Because now we are going to compare 3 different type of data, let's suppose. The one way is because each value is classified in exactly one way. Example include comparison by gender, race, political party, color, or if you want that effect of color, effect of gender, effect of political party on a person income. So this will be a simple example of ANOVA, one-way ANOVA. So one-way ANOVA, as I already discussed, we can only consider only one independent variable at a time. That is why it's called one-way ANOVA. So there are some conditions in one-way ANOVA. So these conditions are also will be hold for the two-way ANOVA. And these conditions are very simple random sample. The sample taken from the population under consideration are simple random sample, just like we took some sample related to the weight loss from those students who drink black tea, or from those students who drink no tea, or from those students who drink green tea. So these are just simple random samples, and all these samples are independent. So mean black tea and green tea have nothing to do with itself. There is no comparison, but these 2 black tea and green tea sample are independent with one another. The sample taken from the population under consideration are independent of one another. Normal population, for each population, the variable under consideration is normally distributed. So, meaning the population data should be normally distributed. Normally distributed means it should be a symmetrical data. Equal standard deviation. The standard deviation of the variable under consideration are the same for all the population. So, as I already discussed, that maybe within data, the standard deviation, the dispersion in the data should be same, but you want to compare different group. So if the standard deviation among the group or the variances among the group are not same, you will not be able to use one-way ANOVA. So starting from the one-way ANOVA test, you need to remember some specific types. So these types are, the first one is null and alternative hypothesis, just like we have already discussed, that let's suppose that you collect data for 3 different groups, mu1 is equal to mu2 is equal to mu3, and alternative hypothesis will be that at least 2 mean are not equal. Okay, so as I already discussed these assumptions: simple random sample, independent sample, normal population, equal population, standard deviation. So this is the first step, that mean of all the 3 groups are same. The alternative will be not all the means are same, or at least one mean is not same. Level of significance, so normally we use this 0.05%, obtain the 3 sum of squares. So now I will show you that how you will calculate these sum of squares. This is called total sum of square. You can denote this SST, total sum of square. This is treatment sum of square, and this is error sum of square. So now we need to calculate. I will show you in a simple example how we will calculate total sum of square, treatment sum of square, and error sum of square. Because we need this for the F statistic. You can see this is our F statistic. So construct an ANOVA. This is one-way ANOVA. This is basically treatment. We also call this variation. These are the sources of variation. This is variation between, and this is variation within. Okay, so you not need to be confused with these error word. Normally we denote this for within, and treatment we denote this for the variation between. And this is basically, as I already discussed in my previous lecture, this is the degree of freedom for between. So let's suppose you have 3 groups. So how many group you have? How many type of data? So 3. Let's suppose 3. 3 minus 1, it will be 2. So in those 3 groups, group A, group B, and group C. Let's suppose you have 1, 2, 3 observation in this one, 2, 1, 3 observation in this one, 1, 1, 4, 3 observation in this one. So how many total observation you have? 1, 2, 3, 9. We have 9 observation. So it will be 9 minus, and K represent the number of groups. So 9 minus 3. Okay, 9 minus 3. So the degree of freedom for this one will be 9 minus 3. 9 minus 3 will be 6. So it will be 6. So 6 plus 2 will be, 6 plus 2 is what? 8. And this, when you sum this degree of freedom, it will be n minus 1, as you know, because we have one independent variable. So n minus 1 will be 9, because n is the size of the observation, and n minus 1 will be 8. So it will be 8. So in this way you will calculate degree of freedom. So I will show you what is treatment sum of square and what is error sum of square, as I already discussed. Then in the next question, in the next step, we will calculate the mean. When you divide this treatment sum of square with this degree of freedom 2, you will get mean treatment square. When you divide error sum of square with this 6, so you will calculate mean. Because this is called mean, because you divide this with their degree of freedom. So in this mean treatment square, so this is the between variation, average variation between. So this is basically average variation between, and this will be the average variation within. So it will give you F statistic value. So if this value is much higher, then and this value is small, so the F value will be very high. If this value is much lower as compared to this one, then this value will be much smaller. So before going to that, now I am just going to conduct a very simple example. But before approaching to that example, you need to understand these things. So obtain 3 sum of square. Number of treatment. Let's suppose in the group 1, A, B, and C. 1, 2, 3. 1, 2, 2, and 3, 1, 1. Let's suppose. So obtain number of treatment. So see how many column, how many group you have. C will be 3. And how many rows? So 1, 2, 3. 3 observation in each group. So R is equal to 3. N will be what? N will be CR. And C is the column. So 3 into 3. So this will be your observation. So you can easily count 1, 2, 3, 4, 5, 6, 7, 8, 9. Correction factor. So I will show you. You need to remember this formula G square N. I will show you what is G. And this is total sum of square, double summation, X square ij minus cf correction factor, which we have already calculated in this one, and treatment sum of square summation j tj square by r. So this is basically the number of rows. So this is, in this example we have 3 rows minus cf, and error sum of square treatments total sum of square. When you get this value, so total sum of square minus treatment sum of square, so you will get error sum of square. So in order to practically solve these things, I am just going to solve a very simple example. Now in this example, you can see, given the data below, test the hypothesis that the mean of the 3 population are equal. Let level of significance is 0.05. So because they already mentioned that we have 3 population data, we have 3 sample data, we have 3 groups. So it will be easier if you use a one-way ANOVA instead of multiple t-test. In multiple t-test, you will compare this sample with this sample 2, you will compare this sample with sample 3, then 2. So you will conduct 4 different t-statistics, and at the end, it will be difficult to interpret all the results. And there will also be a chance that the probability of type 1 error will also be much higher. So you not need to conduct a t-statistic. So now we want to calculate treatment sum of square. So number of treatment. How many treatment we have? How many group we have? 3. So C is equal to 3, column 3. And how many observation in row? So in this, we take one observation, 2, 3, 4. Similarly, in this 1, 2, 3, 4. So we have 4 rows because we have took 4 observation for each sample. So R is equal to 4. So total observation formula was, in the previous slide, it was CR. So C3 into R. So 3 into 4 is equal to 12. Okay. Now we need, because this is 40, 50, we need to sum the column. 40 plus 50 plus 60 plus 65. So 215. We want to sum the column. Okay. These columns. Okay. Don't forget about this S1 square. We want to sum these 3 columns. We will call the sum of this one T1. So Tj means T represent the sum of column. So the first column sum is 215, the second column sum is 251, and the third column sum is 185. So I denote this T1, T2 and T3. When you sum this, so we can easily write this summation Tj, and summation Tj is equal to G, and we use G in the correction factor. So you can see correction factor formula is G square over N. So when you sum this 185 plus 251 plus 215, G is equal to 651. So 651 whole square divided by N, we have already calculated 12. So this is your correction factor. Correction factor is 35316.7. So now we also need to calculate the other parameter. So we just calculated of total observation and correction factor. Now we want to calculate total sum of square. So in this example, I am showing you how you will calculate total sum of square. So for total sum of square, we need to calculate, we need to take x square ij. So what is x square ij? X square ij is, this is x1, this is, if I write this x1, as we already write this x1, this is x2, and this is x3. So the correction factor, the total sum of square formula is double summation xij square. So now you need to take square of this. So this is basically the square of 40 square. This is 50 square, 60 square and 65 square. Similarly, this one is 70 square, 65 square, 66 square and 55 square. Similarly, this one is 45 square, 38 square, 60 square and 42 square. When you add all this, so you can see this is basically the sum as summation x1 square. So when we add all this column, it will be summation x1 square. So this column name is x1 square. 1600 plus 2500 plus 3600 425. It will be 11925. Similarly, x2 square. Summation x2 square. 15981 4900 plus 4225 plus 4356 plus this. Similarly, summation x3 square. 2025 plus 144 plus 3600 plus 17. So this, and when you add all this, so now we will use double summation because this was for the column. You add, this is summation j. Now we add this row. So that is why this is I and this is j. Summation I, summation j, xij square. So when you add all these three, 36739. So in order to calculate, because the formula for total sum of square is double summation ij xij square minus cf. So we have already calculated cf, which is 35316.7. So double summation, which is 36739 minus cf. So this is our total sum of square, which is also called SST. Okay, when we collect this, the treatment sum of square is still remaining. Treatment sum of square is summation t square j. So we have already calculated T1, T2, T3, but the formula is T square. Now you need to take the T square, T1 square. So what will be the 215 square? It will be 46225. What will be the square of 251? It will be 63001. What will be the square of 185, T3 square? So this will, when you sum this T square row, so this plus this plus this, it will be summation t square j. Mathematically we will write this summation tj square. So it will be 143451. So as you know, this is the treatment sum of square, summation t square j. So we just write 143451, and this is row. How many observation in each sample? We have 4, as I already mentioned here. So divide with 4. Okay, minus CF. minus CF, so we have already calculated this, which is 546 when you simplify it. Now the last remaining part is the error sum of square, which is also called within average, which is also called within sum of square. So within sum of square formula is total sum of square minus treatment sum of square. So we have already calculated total sum of square is 14225. So this is 14225 total sum of square minus treatment sum of square, which we have already calculated, 546. So this is 876.25. So I hope you understand this. Now we need to construct a ANOVA, one-way ANOVA table. This is called one-way ANOVA table. So you can see this is the first column, source of variation. In the first instant we will put between sample. So between sample, how many? Between we want to compare all these three groups, between and within. So in each group, within, we also want to conduct within comparison and between comparison. So between sample and the degree of freedom, as I already mentioned, between sample. So you want to conduct a analysis between sample. So how many is normally we also denote with K, but in this we compare this three column. So you can use K or you can use C column. So how many sample we have? We have 3. 3 minus 1. So 3 minus 1 is 2. Degree of freedom for between will be 2. Within. So in within, as I already discussed with you, within will be n minus k. So n minus k, n minus, so n is our n. So how many? 1, 2, 3, 4, and 4, 4. So 12. Our observation is 12. N is 12. 12 minus how many different groups in the data? 3 or 3 columns. So 12 minus 3, it will be 12 minus 3 is equal to 9. And when you sum all these degree of freedom, it will be 11. You can see 11. So basically n minus, this is equal to n minus 1. N minus 1, why n minus 1? Because when you write n minus 1, so how many, what is n? N 12 minus 1, so it will be 11. So now between sample, what is between sample? We have already calculated. Between sample, another name is treatment sum of square. You can also call this is basically between, and this error sum of square is within. So between, what is the sum of square between? 4, 5, 4, 6. So we have already calculated 5, 4, 6. And error sum of square, and the second name of error sum of square is within samples, within group. So it is 876.25, which you have already calculated. Okay. Then you need, in the next column, you need to take the average, because in the F statistic, the formula is average variation between, and this is average variation within. Now we need to calculate average. So how we will calculate average? So sum of square divided by degree of freedom for between. So 546 divided by 2. And how you will calculate average variation within? 876.25 divided by their degree of freedom, which is 9. So 876.25 divided by 9 will be 36. Okay, 97.36. So this is 97.36. Now, because we calculated these average, so the formula for F statistic, which I have already discussed with you, that average variation between divided by average variation within. So average variation between is 273 and average variation within group is 97.36. So the F statistic value is 2.80. Okay. Now we need to construct an F statistic. So you familiar with the F statistic? We start from 0 to plus infinity, and you also familiar with the alpha, which is 0.05. So alpha, this is basically the first one is considered as the degree of freedom between. So this is the degree of freedom between, because we want to compare between and within. This is basically the ratio of between average, average variation between and divided by average variation within. So this is the ratio. So the first degree of freedom, numerator degree of freedom will be, so numerator degree of freedom will be 2 and denominator degree of freedom will be 9. So you will check the F statistic table. Now, how you will check the F statistic table? I am showing you that how we will calculate this for 0.0529. So basically this is our F statistic table. In F statistic table, we are looking for the alpha value 0.05. And our degree of freedom are 2 and 9. 2 is the degree of freedom for variation between, and 9 is the degree of freedom variation within. So this is 2 and this is 9. So basically this is numerator. They already mentioned numerator degree of freedom. So these are the degree of freedom for where? For which? For between. And these are the degree of freedom for within. So we are looking for 2 and 9. So you can see this is 4.26. 4.26. So we will write, this will be the threshold for acceptance region and rejection region. We will write this in the graph. So we just write, you can see 4.26. Now we will compare this F statistic value. This F statistic value lying in the accepted region or in the rejected region. So the threshold for the accepted region is 4.26. So yes, this value lying in the accepted region. So as this value lying in the accepted region, we will accept our null hypothesis and we will reject that alternative hypothesis are not. So the mean of all these sample are same, and the alternative hypothesis that the mean of all these sample are not same, this is wrong statement, because the analysis give us good evidences that the mean of all sample are same.